Hello and welcome back to part 2 of our first video in Unit 6 Exponent Laws in our grade 11 University College math class. So we've looked at multiplying powers with the same base, dividing powers with the same base, and now we're looking at power of a power. So when you have a power, which is a base and an exponent, being raised to another exponent, we call that a power of a power. As with the other two examples, I'm going to work one out here in expanded form so that you can appreciate where this law comes from. And as I said in the first video, they're not laws so much as just shortcuts that if you can remember why they work or why they are, then it's a way to do the calculations more quickly. So in this case, we've got 2 to the exponent 3, so that's 2 times 2 times 2, whole thing to the exponent 4. So 2 times 2 times 2, 2 times 2 times 2, and 2 times 2 times 2. Whew, that's plenty right there. What a great example to have picked. So now if we were to tally these up, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is 2 to the exponent 12. But for those among you who remember, a power of a power, a shortcut for this is to take the two exponents that you have, the 3 and the 4, and multiply them together to give you the 12. So that's sort of the shortcut. Let's have a look at the next example. So here we have 3 to the exponent 2, whole thing to the exponent 3. So this would be equal to 3 to the exponent 2 times 3, which is 3 to the exponent 6. Again, if we have a power raised to another exponent, or a power of a power, we can keep the base and multiply the exponents. Let's look at C. All right, here we have 4 squared to the exponent 5, so that would be equal to 4 to the exponent 2 times 5, or 4 to the exponent 10. All right, one more example here. Y to the exponent 3 times y to the exponent 3, which is equal to y to the exponent 3 times 3, which is y to the exponent 9. And then the little summary down there of our quote law. If you have a power of a power, you keep the base and you multiply the exponents. So there you go. Those are our 3 basic exponent laws: multiplying powers with the same base, dividing powers with the same base, and simplifying a power of a power. So we know how to do those. Hopefully they're quite familiar to you. Now we're going to go through and just sort of rock a few examples here. So our first one, like any time we have a question that has a numerator and a denominator, we want to make sure that we're always finishing up our numerator as best we can before we start bringing the denominator into the picture. So if we have 3 to the exponent 2 times 3 to the exponent 4, that would be equal to 3 to the exponent 2 plus 4 all over 3 to the exponent 3. So let's simplify that numerator, 3 to the exponent 6 over 3 to the exponent 3. Now, we've done our first step. What we have here is dividing powers with the same base. So we keep the base and we subtract the exponents, which gives us 3 to the exponent 3. Now, I do want to point out in terms of ordering here that it is the numerator that goes first, and then you subtract the denominator from it, in case I didn't say that above. So there is our first example. What I'd like to point out here too, and we're going to get into this certainly more as we go through the unit, is the word that we're using for a question like this is called simplify, which means express as a single power with a positive exponent. So where you have a base and an exponent is positive and that's it. It doesn't really care what 3 to the exponent 3 is for that instruction. There will be another instruction that follows called evaluate. That's when you would go on to do what is 3 to the exponent 3 actually. Okay, let's try example B here. Example B, very much like the first one, so this is going to be multiplying powers with the same base. I want to finish up my numerator, so that's going to give me 4 to the exponent 5 plus 2 all over 4 to the exponent 6, which is 4 to the exponent 7 over 4 to the exponent 6. So here we are, division again, so that's going to keep the base, subtract the exponents, and that's going to give us 4 to the exponent 1. Or even just 4 is fine for a question like this. That's example B. Let's have a look at C. All right, C brings in just a little bit more work down here in the denominator, but no big deal. Same stuff. So we've got 5 to the exponent 6 times 5 to the exponent 7. So that's going to be 5 to the exponent 6 plus 7. And in our denominator, 5 to the exponent 3, whole thing to the exponent 3, is 5 to the exponent 3 times 3. So let's simplify those exponents right there. So we've got 5 to the exponent 13 divided by 5 to the exponent 9, We're now dividing powers with the same base, so we keep the base, we subtract the exponents, and that's going to give us 5 to the exponent 4. And same thing for all these. We're not being asked to evaluate, we're just being asked to simplify. So there are our first 3 in this section. Let's have a look at the next one. Again, pretty straightforward here. We're being asked to, now I'm going to start to shortcut this a little bit. We have lots of good references in the notes. I'm going to sort of talk and just sort of do more of these calculations in my head. So a power of a power, as we see that we have here, I'm going to multiply these exponents. So I'm going to get 2 to the exponent 15 here. And in my denominator, another power of a power, so that's 2 to the exponent 4 times 2, which is going to give me 2 to the exponent 8. And now I'm going to be asked to divide these, so I'm going to subtract these exponents, and that's going to give me 2 to the exponent 7. So again, if that's a little bit too fast for you, no problem. You can just hit pause and kind of work through these ones on your own, writing out the extra steps. There's no harm in that. Just for the sake of time in our video, I'm just speeding it up a little bit. Okay, here's E. Numerator's just fine as it is. You'll notice that we put brackets around our negative exponents, since that's not necessarily as important when you're simplifying, but certainly when you're evaluating, it's very important. So here we have another multiply, so we are going to add those 2 exponents together, which is going to give us a 5. And now dividing powers with the same base, keep the base, subtract the exponents, and that's going to give us a 2 here. All right, F over here. This one looks tricky. It really isn't, because whether our base is a fraction or just a whole number or a variable doesn't really matter. The law is applying to the exponents. So in this case, we have 1/3 to the exponent 2 times 3, which gives us 1/3 to the exponent 6. All right, this is looking good. Hopefully we're not going too fast for you here and that you're able to play along. Like I said, not a bad time to hit pause and try a few of these on your own and then just listen to me kind of almost take them up. Okay, now here's what I was talking about earlier. Here we have 2 instructions, a simplify and then an evaluate. So on an assessment, this is the kind of question where there would be a mark for simplifying and then a mark for evaluating. So let's work the first one here. We have 4/5 to the exponent 8 divided by 4/5 to the exponent 6. So that's going to be 4/5 to the exponent 8 minus 6, which is going to be 2. So we have 4/5 to the exponent 2. This, like we were doing above, this is simplified. This is now single power, so a base and a positive exponent, no problem. But now we're going to go on and we are actually going to square the numerator and square the denominator. And that's going to give us a final evaluated answer. So I kind of just cruised by that, but remember that whenever you have a rational base and you have an exponent applied to it, that exponent is applied equally to the numerator and the denominator. So we have 4 squared over 5 squared. That's going to give us 16 over 25. And that is our evaluated answer. So 2 steps to this question. Simplify, which I've indicated here, and evaluated right at the bottom there. Okay, let's try one more. So there's B. We have 1/2 to the exponent 10, whole thing to the exponent 1/2. So first things first, we're being asked to simplify. So this is going to be 1/2 to the exponent 10 times 1/2. Now for those of you who aren't super strong with fractions, 10 over 1 times 1/2. It's numerator times numerator, but I can do a little bit of reducing here first before I go along. So if I divide the denominator by 2 and the numerator by 2, I am left with 5 times 1 over 1 times 1, which is 5. So that's going to give me this, that's the calculation I was doing right here. So that's going to give me 1/2 to the exponent 5, and that is simplified. Now we need to go on and evaluate this thing. And as I said before, remember, evaluating means that we take both the numerator and the denominator and apply the exponent to it. So 1 times 1 times 1 times 1 times 1, I think that was 5 of them, will be 1. Ooh, that's nice, straightforward. And now I like to do this as just sort of an exercise. I usually just talk to the students in the class and say, and I'm holding up my fingers to say, like, what's 2 times 2? 4 times 2 is 8, times 2 is 16, times 2 is 32. So I'm holding up 5 fingers now, so that's 2 to the exponent 5 will be 1/32. If If you want to bang out a calculator for this, again, I recommend that you don't just type in 1/2 to the exponent 5, because that's going to give you a really weird decimal. Go through the steps till you absolutely need to do that calculation, and then maybe if you had to, put in 2 to the exponent 5. Although doubling things should be something that you'd be capable of, I would think. Okay, so again, simplify, that's the first part right here, and then evaluate, that's the last bit right there. There's our first lesson in exponent laws. Crack through that homework and then come on back and we'll get it up with lesson number 2.